Okay, welcome to your lesson on the function of function rule, or what I like to commonly call it, the reverse chain rule. Okay, when we first started calculus back in year 11, we learnt that there were lots of different functions, and in one particular function set up like this, we recognised that you could go and expand those brackets, but the other way around it was to use that function of function or chain rule to differentiate. Okay, so just really quickly, when we were differentiating this, we'd bring that 4 out the front, we'd multiply that by the derivative of the brackets, and then we'd rewrite the brackets and take one off the power. And so we'd all just write our simplified answer like so. And so what we're going to learn about how to do is integrate this function so that it comes back to being that first function we started with. All right, let's go see how to do it. Okay, so we've got to integrate this function, and we are going to have to use this reverse chain rule, right, because it's got those things in the brackets with the power applied to it. All right, so the process we're going to take to go and integrate this. We've got our brackets with our power being applied to it, as we do in this question. What's going to end up is we're going to have the original function written on top, like before, adding 1 to your power, and then you're going to get the derivative of that original function multiplied against your new power, plus c obviously on the end always, because we've got that indefinite integral. Okay, so let's go and integrate this. All right, so using the formula or the idea from above, on the top we've got our brackets. We're going to add 1 to the power. Now, underneath, we've got the derivative of the bracket. So the derivative of 5x minus 9 is 5. We're going to multiply that to our new power. Then it's an indefinite integral, so don't forget to add your constant. And there's our simplification, just fixing up that denominator. Okay, example number 2, we've got to find the integral of 3 minus x all to the power of 5. So the all to the power of 5 says that we do have to go and use that reverse chain rule again. Okay, so when we go and use this reverse chain rule, we write the original brackets on top and we add 1 to the power. So it's going to become a 6. And on the bottom, we take that a value, which in this case is a -1 for that value next to the x, multiplied by that new power. And of course, just don't forget your plus c. All right, now instead of writing the -6 on the bottom, I'm writing a 6, but I'm saying it's giving it this whole thing a negative value with our plus c. Our third and final example for this lesson has this all under a square root. Now it may not seem like a reverse chain rule type thing straight away, but again, we really are being asked to integrate 4x minus 3 all to the power of a half. So now it's a bit more obvious about being a reverse chain rule style question. Being a power of half, though, will cause a little bit of complications later on. Okay, so same as normal, the original part of the function on top, we've got to add 1 to the power, so it's going to become 3 on 2. Now on the bottom, remember, we've got that a value, the value in front of the x, multiplied by that new power. Don't forget your plus c. Okay, so let's start the simplification by putting this back in root form. So it's a square root, but it's this all to the power of 3. And on the bottom, 4 lots of 1.5 just goes down nicely to a 6. If that had not worked nicely on the bottom there, you would have had to go back to your reciprocals, dividing by a fraction. All right, good luck with your homework questions. Remember, submit any questions you're having difficulties with on Google Classroom so we can all help each other out.